It's hard to believe we have about 36 quantum computers we can access online today. Some systems are available through new additions to cloud sites you know, namely Microsoft Azure Quantum and Amazon Braket. Some through system manufacturers' own sites. Is there a way to make it easy for customers to control access and costs, all while providing shorter wait times to specific systems? Sometimes the best quantum computer for your use case is the one you can actually get some shots on. Let's get in the queue on this episode of the Post-Quantum World. I'm your host, Konstantinos Kragianis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. So our guest today is this Chief Science Officer at Strangeworks. I love that title, Chief Science Officer. It feels like I'm talking to someone from Starfleet or something, so that's always fun. So I'd like to welcome Cesar Rodriguez to the show.
Hi. Thanks for having me.
I think from what I've seen, you had sort of a roundabout way to getting into quantum. So if you want to talk a little bit about how you got here.
Yes, absolutely. So it's like, as you can hear from my accent, I'm originally from Puerto Rico, actually. And I was a computer engineering student then. And that was like 20 years ago. I said, I want to program quantum computers. And everybody, all my professors told me I was very crazy about it because they didn't exist. I'm like, yeah, that's what I want to do. I want to help build that industry. I'm very passionate about the history of computing. And this felt like, a second chance to do a new kind of to do computing again, just very different. So I went in deep and got my PhD in physics from University of Texas, and then I worked at Harvard and Max Planck Institutes and several other research institutions until finally I was pulled out of academia to make this thing I was like dreaming about as an academic, make it happen as part of this novel industry.
Oh, that's pretty great. I thought I was in the biz a long time, but 20 years, that's pretty cool. So tell us a little bit about Strangeworks and how you feel that this is the fruition of what you've been building towards.
Yes. So Strangeworks is, we consider ourselves a software startup that happens to be in quantum computing. So we're not doing quantum computing programming to solve quantum problems. We are really doing classical software tools to help those people that do want to do the quantum programming for it. So we have Word Leads, our CEO. He's a serial entrepreneur, very experienced at successful companies before, with a core team that they all know each other quite well. Actually, they've been in other previous startups and with exits and so on. And so they decided to enter this industry. And that's how they dragged me for a common friend. That we have to drag me out of academia to sort of help them out in navigate the waters here. And our offering is that what we're trying to do is a lot of the problems right now to use quantum computers right now. There's a lot of problems from the quantum technology itself because it's so early, and I'm happy to expand on that. But a lot of them, even for the researchers like me, that I can still use it, even though the computers are so very, very early right now. There's a lot of the actual classical software problems. There's a lot of connectivity issues. There's a lot of how do you actually make things work issues. And so what we're trying to do is provide a really broad solution to solve that problem, to allow people to have access to all the quantum hardware out there, to make it easier for them with contracting, with connectivity, with all that, such that people can go from the stage where we are at, which is people are experimenting with what can you do with quantum computing, and they're progressing towards a stage more like evaluating different technologies and where they are. And from then, what we want to help people go is sort of go to an exploration where they start really finding what's the value that they can get from it, to finally, of course, when the industry matures, to be like exploitation, where the people that are doing quantum computing, they do it because it saves them time or saves them money. That's really that's when the industry has matured, and you don't have to pitch, you don't have to explain a lot why quantum computing is valuable. You say it'll save you time or money. And on the industry, of course, it's at this early stage, this very early deep tech, which is more experimentation, evaluation. This is the stage we're at. And we want to help the industry move forward through this process to a mature industry.
When you mentioned some of the things you guys do, like helping basically at a high level, you're helping people get to the machines, right? Too. So when you hear something like that, it sounds a little bit like one of the cloud environments we're all used to. So like, Microsoft or AWS. So how would you compare, let's say, to AWS Bracket? Like what would make accessing machines through you guys a little different?
Yeah, so that is one component. I would say that is sort of the essential component to get things rolling. But our value it goes beyond that, and the value it's basically everybody says, "Oh, the quantum hardware is very early," which is true, and there's a lot of options, which is true. We're evaluating them all, but also just the problems of how do you get the most out of each hardware. For that, you need to use software. I need to program the software. And everybody says, oh, you have the software stack. When you have the hardware, then you have low-level controls and post-control, then maybe some different compilers, and top of that, the languages, and finally, application level and visualization. The thing is, this thing does not exist completely as a whole. A unified is accepted. And there's some more mature ones, like, for example, IBM's Qiskit and so on. But as part of people evaluating technology, not only they evaluate different hardwares, but they're evaluating different compilers. They're evaluating different ways to minimize the errors for the hardware, and so on and so forth. So it's really not just the access to the hardware, but it's the whole software stack. Is how do you have a lot of options so you can mix and match and really improve things for the specific case that you want. So it's that I would say that's the big difference. Is that we're really focusing on the usability of the quantum software stack so that you can make the most out of the hardware, of course. So for that, you need the hardware.
Yeah, that's great. And I've mentioned this a few times that it is a full stack and you can get more performance out of hardware because of the stack. And in the future, we might find future efficiencies, right?
That's right.
So let's say, for example, like with Bracket, that SDK doesn't have Qiskit, but through you, we would be able to use that, right?
Yes, in fact, we have a community, what we call the community version, which is in quantumcomputing.com, and it's just it's intended for educational purposes, for enthusiasts, and so on to get a scope of things. But you can go there right now, and you can see all the software that we support with all these platforms. We support almost everybody, and if we don't, like in terms of hardware and software that's available, and the ones that we don't support yet, we're working towards. And you can like go right now. It's free. This is it is intended as sort of like for people to play with. So you can go and run stuff on real hardware right now. And we have free hardware. We have some free hardware from IBM, for example, that only for us. And we have of course all the free hardware that's out there, and of course the paid hardware that's out there as well.
Are you talking about the 7-qubit machine you guys have sort of exclusive queue times to, or just?
Yes, that is correct.
Yeah.
That is correct.
Okay.
Yeah.
Yeah, and that's pretty exciting. The queue times are getting a little crazy at times, so
yeah.
Any kind of priority edge there is useful. So when you're talking about that full level of the stack, if we just stay here for one moment, because I think this is really important. So if companies are looking to try and get the most out of their experiments and proofs of concept, they might be leaving some performance at the table, right?
That's right.
So as convenient as like cloud providers are, I do every once in a while notice, oh, this is missing, because of course I've seen all the machines and access them in all different ways. So like, for example, with Rigetti, if you were to go directly Rigetti, you have all this extra level control, like pulse level, things like that. And IBM does similar things. But I don't think I see quite that level control in, let's say, something like Bracket. So are you guys then giving that full, like right down to the lowest level?
Yes. So we give the optionality for people to use if they want to use Rigetti Direct or Bracket. Bracket has a lot of advantages too, like the billing and so on. So we think we want to give people the option so they can access Rigetti through one or through the other, basically. And for example, with IBM, they have opened a lot of the as you mentioned, a lot of the exclusives, like more like direct hardware control stuff. Now they're pushing heavily on what they call runtimes, which is sort of a better paired classical quantum compute, so you can cycle better in optimization and optimize algorithms better. And they actually launched it through us before they launched it officially internally through IBM. And so if you want to go use that, if you want to go do some quantum optimization algorithms or some BQE or something like that, you can go to or platform and start running them right now. Just test things out. In some ways, it's a bit easier even than IBM to just run some basic stuff. Of course, there's still like a lot of in-depth stuff that you have to do, and you can choose which way you want to. But the convenience of having all these different ways to access hardware with all the software platforms, it's intended that you can have a place that you can have your own code and run it like this is when you intend to run the same code several times, let's say, to evaluate different hardwares. And you want to evaluate them in time and across the different optionalities, so that this seems to be improving for this use case and so on. And so on top of that, what we're working towards is to provide some basic benchmarking tools and just help the users evaluate their own code and evaluate the different options that they have as well, so they can improve on it and make strategic choices.
Yeah, I think that's important because certain types of hardware and hybrid solutions are the ones that we're going to see performance boost first. And for example, D-Wave's hybrid solver, I believe that's going to be like the first quantum advantage we see. So it's important to be able to access everything, if you want to test the real effectiveness of your code. So you can code first and then select the targets after. Is that correct?
Yes. So we make it easier. So with the different hardware targets, you can compare among them, or compare with simulators and so on. Like, we just really want to make easier the whole workflow of you decide if you need to run more stuff, you decide if you need to run somewhere else. And a lot of this is really comparing live what's happening or as live as possible. So we are really trying to help this iterative process of evaluating the hardware, trying to squeeze a little more out with your code, and that's what our goal is.
And do you do any like internal performance testing, just to like pass on to users, like with Qiskit Runtime? They had some pretty bold claims at IBM about what kind of boost that would give to performance.
Yeah. We don't. We want to be the Switzerland of quantum. We want to be very neutral, and so we have access to, as you said, like IBM and AWS, and we have basically every machine that's online. We allow our users to, and we have very good relations with all the vendors. And of course, each machine has their own like very nice things and what they're good at, and there are things that are like maybe they struggle a little more. And this is healthy for the industry, I think. It's very healthy that users compare them and they start pushing them in different directions. What I don't think the industry is going to go forward just from each individual provider coming up with one metric that they're very good at. Like, what matters is having users, testing them, and seeing what they're more useful for. So in that sense, we don't see value in us telling people, oh, this machine is the best given this metric, because the metrics will change, metrics can be gamed. And ultimately what matters is like usage. So we do want to give tools so that the users can decide for themselves what's more important. And ultimately the usage is the only vote that matters on the race. So we don't want to call winners, but we will for sure organize the race and have everybody race and have the users cheer.
Because there's that community version. Are you also using the other sense of the word community? Are people sharing experiences? Like, when I tried this type of optimization, I found that this hardware worked better. Or are you going to be building any kind of crowdsourced feedback like that for users, or is that just still in the distance future?
So right now the community version is really intended for enthusiasts, and a lot of this more like hardcore tools for benchmarking and so on. We see the more advanced tools, and this is part of our SDK, which is more for private use. So this is more of a productizing, the same access and so on. And these are the extra features that we think are valuable for people to make, because this is how you make strategic decisions. This is really the value we add. It's not the pass-through of the hardware. It's making it easier for people to try it all in meaningful ways and learn from that and improve their code in meaningful ways to them. Like, this is really what we're trying to do. So we see that not so much a part of the community feature, but definitely more of the features of a big enterprise wants to try some use cases. They want to compare around. They want to improve it a little internally, but it is a real pain in the neck for them to set up everything for this one use case And so we try to make it easy for them.
Okay, and the SDK when it first launched, it was basically an online tool, right? Like you just go to it and log in.
Yeah, that's the community version. That's correct. Yeah.
Yeah. So are you now working on a local SDK?
Yes, we do. We have users already. We're still in beta, but we have users from different enterprises and scientific users as well.
And was there a demand for the local SDK for any specific reason? Was it for concerns about privacy, like not giving away too much of what one particular customer is trying, or did they just want to run it on obscure hardware?
Yeah, no. So that's a really good question. We find that there's different kinds of users. There's some people that I just want to test this quantum thing out, figure out what it is. That's really the community version is when it's like, oh, I just want to see what it is. Like, okay, oh, I run, that's interesting. But of course, like when you have a quantum computing, ultimately, it's part of it's a processor for scientific workflows, like scientific computing. That's ultimately the role of it. So it has to fit in within the way people like to use it. So a lot of these things, of course, is local. So one is like the scientists really want to use the visualizations, the standard stuff, make it as tightly integrated with their existing way they do things. And the other one is for some enterprises, specifically said they wanted this, and some of it is geopolitics. Like the quantum computing is, of course, very international, and it's a lot of international competition between different sectors. And sometimes they specifically say, no, we don't want to. We want to keep it in this country, and the SDK is an easy way to help them do that. And other ones were security. There's some companies that care a lot about security, be it intellectual property or other security aspects. Like really, like we don't want some of the countries to spy on us or things like that, or we don't want anybody else. So they did want this locally for some things. Of course, right now with the industry there still has to be some connectivity to the outside. But the idea was like at least they can do some things internally, and then try to limit what they pass through and try to own the code as much as possible.
Okay, and on the flip side of that, are any of these power users also sharing circuits? Are they still being generous back to the community and saying, hey, here's a great way that we found to do this, and you can run this code? Is any of that going on?
Yes, actually, we had some researchers that are publishing papers on this. There was a paper that came out, I think it was 6 weeks ago or something. It was a new compiler that was burned on IBMs, and this was from a team at University of City London. So yes, absolutely, and they put their code out there and so on. So this is absolutely happening, and this is the beginning of it. We think it's gonna keep growing, especially as more people are moving away from just running one use case and publishing a press release to actually evaluating how we're making strategic decisions about where should they put their energy and time on.
You mentioned IBM a few times and Qiskit. Are you planning any other kind of non-IBM technology that's coming? Any other machines maybe? Just like, now you have this access to the 7-qubit machine that's kind of prioritized. Do you anticipate any other kind of specialized access coming for customers?
Yes. We do that. I cannot make the announcement yet, but we'll make it very soon. But the idea is it's really to a similar model that we have with IBM, with special access, make some things freely available for some kinds of users that are like that are chosen like in collaboration with the hardware provider and so on, such that we can give the hardware providers more feedback, and so that the users also get some special perks. As you said, queuing times are terrible. So we do have this that works. I just cannot make a concrete announcement yet. But the idea is really to keep expanding this. We are friends with everybody, and we want or are offering to show that we're supporting everybody, and that we want users to try them all. We really, really, really do. We think this is healthy for everybody, and so we want to be the ones pushing that.
Yeah, that's exciting. And of course, sometimes you record a few weeks before something airs. So to the listeners, you might want to check out the show notes for Strangeworks site, because by the time this airs, there might be more announcements. So
Yes, yes,
you
yes.
might want to see what this machine actually is. And in general, do you find that customers want to pay to shortcut those queues? Are they asking for ways around the wait times, or are they finding them to be kind of tolerable?
No, so absolutely everybody hates the wait times. These are the researchers and the corporation and so on. I would say usually the researchers, the people that actually do the programming, what they want to do is always shortcut the wait time.
Yeah, definitely. I know I want to do that. And before we slip away from this like kind of beta idea, was there another beta program coming that you wanted to talk about? Maybe I know because I had heard about one. I mean, I have some insider knowledge, I guess, but something called Backstage Pass. I don't know if you want.
Yes. Actually, yes. So that was what I was referring to before. That we're gonna have announcements. We call it internally Backstage Pass, but we're gonna make an announcement of additional hardware availability for users, and that it's curated and in tandem with the hardware providers.
Okay, just making sure it was all the same. Okay.
Yeah, that's really. I wasn't sure if I was allowed to say the name. Yeah.
Okay. Are there any ways to then compare the results of what you get, like kind of like reporting or extrapolate a future like performance trends? We're big on extrapolating here. Like we love to do the charts and say, hey, when we get this many more qubits, we can expect this much more performance. So is there anything like that?
Yes, absolutely. Yes, I'm very excited that you asked that because that's really with some of the industry partners that we'll announce very soon. That's exactly what we're doing. Is that what we want is people that have specific use cases to be able to do some very basic benchmarking, running at different hardwares, make some strategic decisions about how good were their answers, how fast did they run, and of course this is like very nuanced. Like it's a lot of work that you do towards that. But there's actually even more. Another layer which you just alluded to, which is we have a lot of hardware. You can compare right now all the hardware. That's good. But in 6 months, it's going to be a lot more hardware online, and we're going to support even more stuff. Can you compare across times, and so on? So you can have a trend of how is this performance, this specific use case, how is it performing? On top of that, then you have some of the big enterprises. They have many use cases they're interested in. And you can group them together to get a trend for this area of interest and see how they're doing and make this kind of analysis. And once you do that, of course, you can make also broad industry trends, right? If these areas belong to these industries, this seems to be like a little harder for people. And this helps industries themselves to, and enterprises and industries, it really helps enterprises to just decide, like what everybody wants to know. When should I start in quantum? When should I start in quantum? Where is that inflection point that happens? Where is that crossing point? And I call that point. There's a lot of names for it, but I personally like to call it because it's the big name. I call it quantum value, which is when you can explain that you should do quantum because it saves you time and money. And so everybody wants to know what that is. And the truth is, nobody knows. And there's nothing wrong with that. Like if somebody tells you they know when that happens, don't trust them, is what I would say. However, but of course, the enterprises need to prepare for this point. And I do think there's a lot of value right now in this uncertainty of helping them navigate that so they can make their own strategic decisions. They can grow the teams as they see fit. They can focus on the hardware that they find more useful through these reports and these trends that are moving forward. That's really our value is we are very honest, and we recognize that there's a lot of uncertainty in the industry, and that means that we can help people out navigate this, and because there is a lot of value to be made.
Yeah, because you guys are framework agnostic, hardware agnostic, it looks like you could just focus more on managing the whole experience, right? Because there's costs of hardware on the back end and all that kind of stuff. And I think it's only going to get more complicated, honestly, as more and more companies. This kind of reminds me of when the cloud was getting big. There was this concept of like cloud of clouds, like you would have some company manage all your cloud accounts and all your access. And I almost feel like this is sort of like a cloud of quantum clouds or something.
Yeah. That is definitely, like, I would say, like a critical aspect of it, because without that, none of the other things make sense, right? That is an essential part of our offering. But we're trying to, go beyond that. Not only give them access to all of them, but help them decide where should they put the money in. And part of the cloud of clouds, a lot of it is like it's not really like the difficulties of writing the right line of code to make it work. It's a lot of it is the business side of making the deal and like buying the hardware, and each company has different ways they do it and different rules and such, and and we have to treat everybody different, and they change the queuing systems every now and then. So there's a lot of just traditional like business problems and engineering problems that we try to manage, so that we do it once and then all the users benefit, as opposed to each single programmer having to pull their hair trying to make this happen.
Would you be able to then use sort of like a buying in bulk power strategy in the future? Would you be able to buy a bunch of time and divvy it up for smaller users?
Yeah, so that one is that's it depends on the hardware provider. They each one has different. Everybody, they're all very different, and they have different policies on this. Mm-hmm. However, I would say that because the good relationships we have, we for sure have been able to sort of convince some hardware providers to sell some smaller pieces than they'll normally do through us. So there's already like they do understand the value. This helps the users, of course, and it helps the hardware provider as well. I would say like right now, like to make a big investment to buy a lot of compute time. It's something that's in the cards for sure. Of course, that's a big play, right? Like it's a really big play for a start of our stage, but it's something that we definitely keep in mind.
It sounds like you're doing a lot of the business facilitating.
That's correct.
On the back end. Yeah. And I do believe that's going to become increasingly important. Costs can get out of hand really quickly here. I've said it numerous times, we always get a little nervous when we're running certain POCs because, you try to predict the cost of a shot even, or how many shots it'll take, and things get a little scary. So Honeywell, they have a great tool that predicts that. So do you guys just then sort of pass along any APIs to something like that to the customer? So like so any kind of estimators, like do you have any that you create, or do you just pass along whatever a company does to estimate how much it will cost to run?
So there's different areas one can estimate. Like there's some basic stuff. And it's very difficult to make a good guess. Mm-hmm. So what we do is we have many of them, and allow people to mix and match what they see fit, with the understanding like we cannot make their prediction, but we for sure can like help them make their own predictions to make smart choices about this. Like do I want to? Is getting some extra this precision digits? Is it worth my money, for example, or is it worth my time, or such things? So there are things that we really believe in, while we also recognize that there's some unpredictability. However, there's a lot of opportunities just on cushioning some of these unpredictabilities and fluctuations for the users. And these are things that depending on user feedback, we might make several decisions about do we work this way or that way to help them out with that. So we're definitely at a stage where we're like having our first enterprise users and like really getting the feedback to see which areas of this they will benefit the most from.
Yeah, it would be interesting if that kind of information could be shared between users sort of without revealing anything sensitive. That, the last 1,000 shots we ran of this type of problem, each one cost approximately this on these machines. And then you could sort of start having those available to people so they could see. That might be useful. Do you have any kind of...
Absolutely. Of course, like in helping everybody do all this experimentation, there's a lot of very valuable data that we have about the whole industry and where things are going, what is useful, what people do use, how do they use the hardware, and so on. So these are things that we definitely want to use to help users even do better. So this one you have is like one example of that, but this is certainly the area that this is exactly where we're directed towards. Yeah.
And so you have accounts obviously that you create for Strangeworks. So people have credit and whatever that they're using in your account, so they can be billed directly that way to use the machine, or can they also bill to their cloud accounts, like if they have some volume agreement or something, let's say Microsoft.
Yes, absolutely. Like if they already have access to the machines some way, they can use their keys and they work great. And if they need help getting that, we can help them as well. Absolutely.
Great. Yeah, that sounds like a good approach. Do you have any kind of throttling in case you want to have some like division of like trainees or something, and you're worried that they're going to run up a huge bill because they don't know what they're doing?
Yes, we call this sort of team tools, and they make sense for big institutions, of course. And this is as you mentioned, this is just a classical problem. This is nothing quantum about that. Mm-hmm. But the management of the credits, the sharing, and so on. If you're a researcher, you don't have so much money. You want to make sure the grads don't like burn it all up or something. So we think there's a lot of value in that, and we do have this team features, team management features, and also at the higher level, so the institutional level, for when a big institution has a lot of research, like a big university or a group of universities, they have many researchers in that. How do they allocate? The university might buy the credits, how to help them to best allocate it properly. So this is a lot of those tools that we have to make it easier for people to have access.
So I guess the best way to get started with something like this would be just for people to go to the community version, right? And see what it's all about.
Yeah, absolutely. You can go to quantumcomputing.com. We have some examples there. And if you create an account, then you get a cool URL like quantumcomputing.com/your name.
Yeah, I was going to say, someone had to nab that URL eventually, and you guys took it first. So congratulations on that one. It's just so obvious. and of course, in the show notes, we'll mention that and your company's site too. So yeah, wow. Thanks for giving us this insight. I think the business side is really going to be impacted heavily by this sort of like new cloud of cloud approach. So it's exciting to see what you guys are doing. Thanks again for coming on.
Thanks for having me over.
We're adding a new short segment here called Coherence, the Quantum Executive Summary. I just want to take a moment to highlight some of the business impacts we discussed today in case things got too nerdy at times. Let's recap. There are about 36 quantum computers available right now. Some are accessible by multiple online services, and depending on how you choose to access these machines, you're given different levels of programming control. Getting the most out of the quantum software stack can be tricky. Strangeworks is a company looking to solve traditional business challenges around using emerging quantum technology. A few years ago, companies started managing multiple cloud accounts for customers to create a cloud of clouds approach. Strangeworks is doing the same for quantum access. Unlike some other quantum companies, Strangeworks is more engineering heavy than physics heavy. They're focusing on facilitating business and relationships between customers and providers. As quantum computers get more powerful and time on them becomes even more precious, this approach of managing access may become crucial rather than a nice to have. We may even see benefits from what Strangeworks learns by working with more customers and providers. Perhaps better efficiencies or ways of estimating costs. And their throttling feature sounds pretty handy if you have a department of experimenters that may get a little too curious for a particular quarter's budget. You can learn more by visiting the links in the show notes and maybe starting with the community edition. That does it for this episode. Thanks to Cesar Rodriguez for joining today to discuss Strangeworks. And thank you for listening. If you enjoyed the show, please subscribe to Protivity's The Post-Quantum World and maybe leave a review to help others find us. Be sure to follow me on Twitter and Instagram at Constant Hacker. That's constant with a K, hacker. You'll find links there to what we're doing in quantum computing services at Protivity. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protivity.com or follow Protivity Tech on Twitter and LinkedIn. Until next time, be kind and stay quantum curious.